Question 13. Sketch the graphs of y equals 1 plus x to the n for integer values of n from 0 to 3, each on a separate set of axes. Which points are common to all graphs? Okay, so let's start off with n equals 0. So then we're left with y equals 1. It's fairly straightforward. Y equals 1 is just a straight line going through 1 on the y-axis. Next, n equals 1. So this is y equals 1 plus x. So you should be able to see that this will be a straight line of some sort with gradient 1 and intercept 1. So we know that if x equals 0, then y equals 1. And if y equals 0, then x equals minus 1. And we know it's a straight line, so the straight line must just go through these 2 points. Apologies for the wiggles, my pen isn't actually accurate enough to draw that sort of straight line, but I promise you that's a straight line. Next, n equals 2, so that would be y equals 1 plus x squared. So we know that this will be a parabola, and we know that when x equals 0, y equals 1. So again, similarly, we cross the y-axis at 1. And when y equals 0, we cross the x-axis at minus 1, just the same as before. So now, just so I can draw this a bit better, I'm going to remove what I've already drawn on, draw the parabola, and then add the stuff later because I'm terrible at drawing. So I promise you again that is a parabola. Right. Next, n equals 3. That's y equals 1 plus x cubed. So this is a cubic graph. Again, extremely similar to the last cases. When x equals 0, y equals 1. And when y equals 0, x equals minus 1. So you should know the general shape of a cubic graph. So I'll just draw the shape on, and then I'll draw the sort of crossing points on afterwards. So it sort of comes up like this, hits the x-axis, and then goes up like this. So something similar-ish to this. And again, apologies for the strange wiggles. They should be more curved. Let me try and draw that again, actually. Yeah, I think that's the best we're going to guess. So that's minus 1 and 1. And the question says, which points are common to all graphs? So you should be able to see common point is 0, 1. And then also, for all but n equals 0, we've got the common point minus 1, 0 as well. But I guess, technically, if we're being really pedantic, they're saying which points are common to all of the graphs, which is why I've put this in the square brackets, because we don't, you wouldn't want to be drop marks for that, because you clearly know that it's all for all but n equals 0. Next, describe 2 of the further features common to all of the graphs for n greater than 1. So we're only caring about n equals 2 and n equals 3 in this case. And I suppose if we really want to, we can apply this to any n greater than 1. You should be able to see we have a stationary point. Which is minus 1, 0. And we'll have that stationary point for all integers n as we keep going. And also, as x tends to infinity, so as x gets bigger and bigger and bigger, y will also get bigger and bigger and tend to infinity.